time along road is going to be what? Well, there are x feet to cover, and we're going 6 feet per second. So let's see, the distance, well, let's work this out. The distance, x feet, is going to be what? The speed times the time. So the speed is 6 feet per second times the time. So the time it takes will be x feet divided by 6 feet per second. So the time would be x feet divided by 6 feet per second. And if you do the algebra on the units here, you know, when you divide, you invert and multiply. And when you invert and multiply, the feet goes into the denominator. These feet cancels, and it's going to leave seconds because it gets inverted up top. So this is x over 6 seconds. Okay. So for example, if you walked 60 feet at 6 feet per second, 60 feet divided by 6 would give you 10 seconds, wouldn't it? It would take 10 seconds to walk 60 feet. So if you're a little uneasy about the abstractness of these symbols, then try plugging some simple numbers in there and make sure it worked for you. If I walk 6 feet every second, for 10 seconds I can go 60 feet. All right, 60 feet over 6 is 10 seconds. Makes sense. So I know what this time is. It's x over 6 seconds. So let me just pencil that in up here, or marker that in. X over 6 seconds. And that way I can erase all this stuff here. Because the next calculation is going to involve Pythagorean theorem and square roots. It's going to be messy. So let me erase here. And because this was certainly the easier one. All right. The triangle is, let's see, what color should I've used about all my colors, haven't I? This is going to be how long? 400 minus x feet. Total length of 400 minus that portion is 400 minus x. The height is 150 feet, so this, and let me just call this L for the moment. 400 minus x, so the base squared plus the height squared is the length squared. So the length of this diagonal length would be the square root of this left side here. 400 minus x, quantity squared plus 150 squared. All right, now you cannot distribute the square root through here and get 400 minus x plus 150. Absolutely wrong. That's a huge error to distribute a square root in terms inside a sum. So we're going to have to leave the length at that. But it's in feet. And how long will it take if you're walking 3 feet per second? Well, if I take the length or the distance and divide it by the speed, let me write that out so I don't confuse it with seconds. And the speed is 3 feet per second. I have the same type of calculation I had before. When my units are feet over feet per second, you know, this ends up being feet, invert and multiply, seconds over feet. Then the units here, the feet cancels and gives me seconds, which is what I needed. So I needed time. And so taking this length, which is a little ugly, it's the square root, divided by the speed it takes to walk over the sand, 3 feet per second, I get the time it takes. So the time would be simply the square root divided by 3, wouldn't it? So this would be, let me write this out, square root 400 minus x, parentheses squared plus 150 squared, everything divided by 3. All right, now don't attempt to divide the 3 inside there. You know, the only way you could bring the 3 inside is if you made it a square root of 9, and then you would be dividing by 9, not 3. Alright, so I have this time, and this is time also, seconds. So I have those 2 times calculated. We can write the function now. And like usual, I have not enough room on my board to spread everything out as wonderfully as I would prefer to. So I'm going to have to erase this part, and now we can write the answer. So I've already defined my function up here. F of x, which is the time it takes, will be x over 6, this little portion, plus this monster over here, square root parentheses 400 minus x quantity squared plus 150 squared over 3 seconds. Alright, so there's my final answer. Okay. A little ugly. Don't square 150. That would be, what would that be, 22,500. It'd be a big number. It's not terribly meaningful to us. I would keep it like this and be done with it. In fact, for calculus purposes, it's actually more convenient to leave it in that form. So, anyway, I've worked one kind of like this in my book, and if I remember right, I think I actually did work out the shortest time in the problem in my book, and showed you what it looks like in terms of the graph and so forth. So I go in a little more detail about the mechanics of this once you get to the calculus stage. Hope you find that interesting. But here's this problem, and it's probably one of the tougher ones you would see in college algebra. But does it really use anything you haven't learned before? Okay. What's the real challenge here is taking all your knowledge and putting it all together like this. And so I hope you gain from looking at this problem.